We're going to continue multiplying polynomials, specifically binomials, in this section, and it's called special products. It really, if you don't know the patterns after this, that's okay, because if you just multiply them out using FOIL or something like that, or the distributive property, you'll still get the same answer, even if you don't recognize that it's the square of a binomial, or it's two conjugates that are being multiplied together. It's okay. But we will be doing factoring pretty soon, which is the reverse of what we're doing right now, which is the reverse of multiplying, and so you'll have to know those patterns then. So anyway, let's multiply these. We're squaring x plus 8, and we're squaring x minus 4 here. So let's start with this one. So remember, x plus 8 quantity squared is really just x plus 8 times x plus 8. And so I can use FOIL if that helps you, or we can, I like to just multiply, take the first one here, multiply it by both of them over here, and then move on to this one and multiply it by both of them over there. So I've got x times x, which is x squared, and then x times 8, so plus 8x. And now I move to the 8, and I've got 8 times x, which is also 8x, and then 8 times 8, which is 64. I can combine my like terms, and so I get x squared plus 16x plus 64. Now there's a pattern that's happening here, and that will continue to happen when you're squaring a binomial. We'll come back to it. So this would be our the square of x plus 8. So let's square x minus 4 now. So I've got x minus 4 times x minus 4. And again, I'm just going to run through this, and we've got x times x, which is x squared. And then we have minus x times 4, which is 4x. And then again, we'll have a minus, and that'll be 4 times x, which is also 4x. And then it's actually easier to see here if I written this as an addition statement, like if I change this to plus, negative, and plus, negative, what I end up with is it would be plus, and then negative 4 times negative 4 is positive 16. So what we get is x squared minus 8x plus 16. Again, there's a pattern here. And to really see the pattern and know what happens, let's just do we'll do a plus b quantity squared. And so this is a plus b times a plus b. And so I get a squared plus ab plus ab plus b squared. And if I combine my like terms, I get a squared plus 2ab plus b squared. And this is the pattern, the binomial squares pattern. So you'll notice my first term, which is the a here, I've got a times a, so I've got a squared. So here I had x, so which would be x times x, so I've got x squared in my final answer here. And then in the middle, this term and this term, I did a times b, and then here I did b times a, and I just wrote it as ab and ab. And so we ended up with 2 ab's. So if we look at this, I've got 8 times x, so that comes from this 8, this x times this 8. And then this 8x comes from this 8 times this x. And I've got 2 of those, 8x and 8x, so it's going to give us 2 times 8 times x, which is just 16x. So 2 times the first term and times the second term. So if I did the first term here, which is, let's do x times the second term, which is 8, and then multiply that by 2, I would get that 16x. And then the last term is just going to be the square of the second term here with the square of the 8, which is the 64. And that same pattern happens if we switch it up and we do a minus b squared. You end up with a squared minus 2ab plus b squared. And so that's if you have a difference in there in your binomial, you get that. So we're going to move on to another one, and we're going to define this conjugates here. So conjugates this is a pair of binomials that each have the same first term and the same last term, but one binomial is a sum and one binomial is a difference. For instance, x plus 3 and x minus 3. These two binomials are conjugates. They have the same first term, the same last term, but this one is a sum and this one is a difference. Okay? Again, let's do some more conjugates. So you could have like m plus 5, and its conjugate would be m minus 5. Or we could do 3x minus 2, and its conjugate would be 3x plus 2. So let's multiply a few of these conjugates together and see if we can come up with a pattern. Let's multiply x plus 7 times x minus 7. Notice these are conjugates, and so when I go to multiply these, I'll do x times x, so I get x squared. Then we'll have minus, and then it'll be x times 7, which is just 7x, and then 7 times plus the 7 times x, and then minus 7 times 7, which is 49. So what we get is this minus 7x plus 7x, that's going to cancel, they're going to cancel each other out. So what you're left with is x squared minus 49. Let's do another one. So if we have x plus 3 times x minus 3, we'll get x squared minus 3x plus 3x minus 9. Again, these middle terms are going to cancel each other out, and we'll get x squared minus 9. And so the pattern here that you end up with is what's known as a difference of squares. The product is called the difference of squares. Notice I have a difference, this is a perfect square, and this is a perfect square. I have a difference, this is a perfect square, and this is a perfect square. So if you have something like a plus b times a minus b, we will get a squared minus ab plus ab minus b squared. Minus ab plus ab, those will cancel each other out. I'm left with a squared minus b squared. This is the pattern for when you're multiplying conjugates, and it's always going to be the square of your first term minus the square of your second term. So the square, our first term was a in our binomials, and our second term was b, and so the first term, it's going to be a squared down here in our product, and it's going to be b squared in our second term of our product, and then it's going to be the difference. So it's we call this the difference of squares. All right, so that's the stuff from this section, and let me know if you guys have any questions at all. Maybe I'll put a summary, little summary page up here just to summarize the binomial squares and the product of conjugates. All right, so here's kind of a summary of what we just did. So we've got our square of a binomial here, and we've got our product of conjugates here, which produces the difference of squares.